So my job here and my colleague Chris Small was to look at houses design and test concrete. So we were looking at strengths of the concrete and bricks. So we had these two different groups, one doing survey with population, another one doing physical measurements on the ground.
Mm-hmm. So what else? Do you have other?
Yeah, this is my tool actually. This is called Schmidt Hammer. And Schmidt Hammer is a tool which consists of spring, which is inside the cylinder. Mm-hmm. And this is actually a sensor itself. It's just a steel rod, which you put towards the wall. And then you press the cylinder, and there is a spring inside, and there is a weight. And weight hits this rod, and basically it returns back the value of compression.
So it measures vibration.
Strength. How strong is...
Oh.
So because
how strong the building
how strong the material is.
Oh, I see.
Either brick or cement. Because it returns back. When spring with a load hits this rod, it returns back. So for example, if you have a soft material, you will not get big returns. The value will be very small. If material is very strong, it will just bounce back very fast.
So you use this equipment to basically tell what kind of construction they have?
Yeah, yes. Strong or not strong, what the strength of material is. Now, this tool also is used, I'm a geologist, and that tool is also used to define weathering of rocks, strengths of rocks. So if rocks are weathered, which means they're very weak, then you get very low signal of strength. If rocks not very weathered, then you get very high signal of strength. So this device is used intensively in geology. And what we did testing of bricks. You see the pieces of bricks here, and also some cement, which is between bricks.
So you tested the bricks that had fallen?
Yes.
Houses that had fallen apart?
This is an example of how we did our survey. That's a remote sensing image. It's from QuickBird, one you can see in Google Earth. Mm-hmm. And then from here we can find ourselves in the corner of a street. And there's two arrows. So from here you can see that area which is devastated, that the house which was collapsed.
That's what you're looking at from that area.
And then from here you can look here and you can see another house in the corner which collapsed. And this is an example of the wall. So this is it's a cement between red bricks, and those are bricks. And as you can see actually here, this house is standing, but this one collapsed.
So it's brick stronger?
It's a strong house. It's a brick.
Brick makes it a stronger house than if
brick
it's just...
makes a stronger house. However, design. As you can see here, you can see the columns here, vertical ones. That's called reinforced masonry. So it reinforces house, keeps bricks together, because when you get a vibration, you get the lateral displacement of bricks. So if they hold, they're much stronger. Now, this house apparently didn't last. And if you look here, you'll find that the basement of the house is built from adobe. That's not even a brick. This is a brick here, but this is adobe. It's
two totally different types of construction.
It's a different material. Adobe is basically the same clay, but it's not burned in a kiln.
So right there, by looking at that picture, you were able to tell this house fell because of this material, and this one is still standing because of this material.
That's right. Yes, that's right.
Wow.
And what we did, we tested this brick properties and cement properties, and we didn't test adobe because this tool doesn't test adobe. It's too weak for that. And this is another example of the same thing. That's a corner of the street. This is a collapse of the building, and you can see it on an image of the house. This is a similar thing. That's destruction in the middle of the block of Plaza d'Armas. So if you look from here and you see this empty space, that's basically what it is. The whole thing collapsed and was cleaned after earthquake. Those are examples of actually destruction. So you can see also reinforced building, so masonry with vertical columns. And this one totally collapsed. Some part of it still stands, but apparently it was not built by the good design. This is a famous place in Chincha where 200 people were buried right here.
Buried inside the church.
Inside the church when it collapsed, exactly.
Yes, I heard about that.
And so that's what you see. It's what left from this whole big cathedral. And where you see these wires and stands, there was a service in the memory of these people.
Wow.
And so but the actual collapse occurred here where 200 people were buried alive almost. Here we see also interesting thing. We found this is what you see is a remnant of the building. There is nothing on the top, there is nothing on the right, nothing on the left, bunch of rubble. And you see sign here, which says, be careful in case of seismos. In case of seismic event, you should stand here. And you see, if you would stand here, nothing would happen to you. So that shows how actually a warning system which engineers put together, it works.
So you have to stand at the frame of the door.
You have to exactly right here, because that's the strongest part of the building. So you don't go back and forth. But I think that when earthquake lasts for 160, 80 seconds.
Now, is that true for any building?
Depending on the structure, but I think it's most for like 90% it would work. Also, like, because one of the reasons, because this thing is very small, so the pressure which you apply on the top and lateral, this thing will not collapse. It will stand, basically. That's the idea. It's like people recommend to go to bathroom. If there is earthquake, go to bathroom and just stay there. It's not a funny thing. It's not a joke. It's a real thing, because bathroom built, it's very small, and it has reinforced. It's all.
Well, it's the same thing with a tornado. They tell you keep going into a room, inside another room, and hide in the closet if you have to.
Right. For some reason, there is a reason to that. This is as you can see, this is a lady living in a house, and this is her cooking stove. You can see living conditions very poor. It's adobe house. Again, it's all adobe, and
so a lot of people displaced, left homeless.
Well, they got
living in tents.
Yes, you will see that.
I saw some pictures.
This is a very simple thing. You see here is a tent. It's a white wall. That's a tent next to this house. And those are tents, as you can see. So again, this is reinforced masonry with the big columns and so on. It stands, and those tents were brought by Red Cross, and you can see them a lot on the streets. So it's very difficult to also move around. Now it's easier, but the streets with debris prevent trucks and cars to go through. This is example of also big tents, and you see this house intact, but then this guy's living.
And this is what, 8?
That's
6 months
5,
later?
yeah, 5 months after earthquake. And the issue is that Ica, actually, town of Ica was cleaned very nicely, but other towns not so good, so I think the help come later. This is also example of this reinforced masonry, which you can see, and it stands. And this is just a person walking down with a bucket.
Trying to rebuild, I guess.
Yeah, that's another, this is a collapse right here, and this reinforced structure standing totally intact. But you have to keep in mind that this has cost money. So that's where it goes into economy, how to make structure safer, you need more money. This is an interesting thing. You see this house, which is apparently reinforced, but you see the crack went through. It didn't collapse. There is another crack right here. So the house is actually almost on the verge of collapsing. And that's the biggest danger when people return.
When you see houses like that, you have to
move out.
Seal them out.
Yeah. And you have to actually, demolish them.
Well, I went to I covered an earthquake as a reporter in Armenia, Colombia, and I got there, like you, after it was over. Although there were still aftershocks, I felt a couple of aftershocks when I was there. But I was in a hotel, and there were cracks. I mean, I'm staying in the hotel, and it had cracks on the wall all over. And it sort of scared me, because maybe we should vacate this place. We'll be right back, Professor. Hold on, and we'll be talking to Professor Gorokovich. I got it right. And Andrea Diaz, one of the students who went with him to Peru. We'll be right back.